The Cenozoic's first herbivores were disasters, how Condylarths failed before mammoths inherited the earth. But here's what nobody tells you, and I mean nobody. The real reason mammoths conquered North America wasn't because they were stronger or smarter. It was because they inherited a continent already broken by creatures that failed so catastrophically that they reshaped the rules of survival itself. Stay with me, because by the end of this video, I'll reveal the one signal that predicted which herbivores would dominate and which would vanish without a trace. A signal that still matters today. If you've spent any time watching Ice Age documentaries, you know the story. Mammoths came, mammoths ruled, humans arrived, mammoths died. Clean, dramatic Hollywood. But that narrative hides something deeper. Before the mammoths, before the dire wolves, before the saber-tooth cats that would hunt them, there were the Condylarths. These weren't the giants we celebrate. They were smaller, stranger, often overlooked in the fossil record, and their failure set up everything that came after. I'd love to hear from you in the comments. Have you ever wondered why we focus so much on the Ice Age megafauna and so little on what came before? What drew you to this channel in the first place? Now, before we go deeper, and I need you to stick with me here, there's something crucial I should mention. The complete mechanisms behind why certain herbivore lineages succeeded while others collapsed, the exact evolutionary pressures that created the conditions for mammoths to dominate, all of that is covered in my in-depth guide on Pleistocene herbivore evolution. You'll find it in the description and pinned in the top comment. It's a paid resource, but it contains the keys to understanding not just Condylarths, but the entire trajectory of North American megafauna. Here's the truth that shifts everything. Condylarths weren't just early herbivores. They were the first serious experiment in large-bodied plant eating on a continent recently emptied of dinosaurs. The Cenozoic was brand new, the climate was unstable, the vegetation was still figuring out what to be without the constant pressure of massive reptilian browsers crushing it flat. Condylarths moved into this chaos with bodies designed for something the Paleocene and early Eocene hadn't yet demanded: efficient, prolonged grazing and browsing across sprawling territories. Their teeth tell part of the story. Specialized grinding surfaces, wear patterns indicating a diet heavy in vegetation. Not the flat molars of later grazers like mammoths, but something intermediate, a compromise solution. Condylarths were trying to solve a problem that didn't quite exist yet. The grasslands hadn't evolved their full defensive chemistry. The shrubs hadn't developed the toughness that would later demand bigger jaws and stronger jaw muscles. Condylarths arrived too early. Diversity is usually a sign of evolutionary success. More species, more forms, more ways to solve the same problem. Condylarths diversified rapidly. By the mid-Eocene, dozens of Condylarth lineages occupied different niches across North America. Some stayed small, scurrying through undergrowth. Others grew larger, moving into more open territories. Some developed processing teeth for tougher plant material. Others kept simpler dentition, perhaps feeding selectively on softer vegetation. This should have spelled long-term survival. Instead, every single lineage failed. The climate shifted, gradually, unevenly, but relentlessly. The warm, humid Paleocene gave way to a cooler, drier world. Rainfall patterns changed, seasons became more pronounced. And here's where Condylarths discovered the problem they couldn't solve. Their bodies were built for efficiency in a stable climate. Smaller brains relative to body size meant less metabolic flexibility, less capacity to store fat for seasonal shortages, less ability to migrate long distances when local resources dried up. Condylarths were specialists in a world that was becoming unpredictable. Their teeth tell a story of desperation. The wear patterns on Condylarth molars show they were grinding tougher, coarser vegetation toward the end of their dominance. Plants that required more energy to process and delivered fewer nutrients in return. They were eating their way through a closing door, consuming more and more of a landscape that was producing less and less. Within a few million years of the Paleocene's warmth, the gap between what these animals needed and what the world could provide had become fatal. Meanwhile, something else was happening. Far from the Condylarth strongholds, a different kind of mammal was appearing: ungulates, true hoofed animals, perissodactyls and artiodactyls, the ancestors of modern horses, rhinos, pigs, cattle, and deer. These newcomers didn't arrive from nowhere. They evolved from smaller, less specialized stock. They were simpler, their teeth were less modified for specific foods, their digestive systems were less demanding. Most importantly, they possessed something Condylarths lacked: flexibility. An ungulate could eat leaves one season and bark another, seeds when fruits disappeared, grasses when the forests thinned. Their hooves gave them mobility across changing terrain. Their simpler metabolic architecture required less fine-tuning to survive through unpredictable years. They weren't optimized for one perfect world. They were built to endure a messy one. And as the Paleocene gave way to the Eocene epoch, that adaptability became the only currency that mattered. Condylarths didn't vanish overnight. Extinction is rarely that theatrical. Instead, their populations shrank. Breeding success declined. Generation by generation, they produced fewer offspring. Their ranges fractured into isolated pockets, and in each pocket the same pressure repeated. A world that changed, a body that couldn't keep pace, fewer animals born to the next generation, until finally, silence. Some Condylarth lineages persisted longer than others. A few managed to survive into the early Eocene, clinging to tropical refuges where the climate remained warm and stable. But they were ghosts, evolutionary dead ends. The momentum had already shifted. The future belonged to the ungulates. By 30 million years into the Cenozoic, Condylarths had completely vanished from the fossil record. Now, before we continue, I need you to hold something specific in your mind for just a moment. This pattern we're discussing right now, this dynamic of specialists losing to generalists when the world becomes unstable, it's not unique to Condylarths. It echoes forward through the entire Cenozoic. And if you want to understand how this same mechanism played out again and again, how it determined which species inherited the Earth during the Ice Ages, why mammoths thrived while saber-tooth cats ultimately couldn't adapt, what patterns separated the survivors from the vanished, our complete ebook on Pleistocene ecology is available in the description and pinned in the comments. It breaks down the mechanisms of extinction and adaptation across every major Ice Age predator and mega herbivore. It's a paid resource, but it cuts straight to the foundations of how these animals lived, competed, and disappeared. The ungulates that replaced Condylarths were more than just survivors. They were architects of a new kind of ecosystem. As they diversified over the next 10 million years, they changed the landscape itself. Hoofed grazing animals don't just eat plants, they shape them. Their movement patterns, their selective feeding, their migration routes carved new pathways through vegetation. Grasslands began to expand where browsers had been the only large herbivores before. Predators evolved to chase them. Scavengers learned to follow behind. The entire structure of mammalian communities was being rewritten, and it was happening because Condylarths had failed to adapt. This is what makes the Condylarth extinction so significant for understanding North America's Ice Age giants. The first major mammalian order to inherit the Earth after the dinosaurs didn't fail because they were unlucky. They didn't vanish because of a single catastrophic event. They disappeared because the world changed and their architecture couldn't bend with it. Specialization was their strength. Inflexibility was their death. 2 million years later, when the first true elephants appeared in North Africa, they carried that lesson forward, even if evolution works without intention. They were built with adaptability baked into their bones, large brains, omnivorous teeth, the ability to store resources, migration capabilities over vast distances. They could survive drought, they could adjust diet, they could learn from their environment and pass that learning to their offspring. Long before a single mammoth set foot on American soil, the ecological template had been set. And Condylarths, now extinct, now forgotten by all but paleontologists, had written that template in their failure. When mammoths finally arrived in North America, roughly 4 million years after the first elephants emerged in Africa, they inherited a continent that had already learned how to kill the overspecialized. The grasslands were there. The migration corridors were worn into the earth by generations of earlier herds. The water sources followed predictable seasonal rhythms. Everything a giant herbivore could want seemed to be waiting. But the landscape itself was a graveyard of failed experiments. Condylarths had occupied nearly every herbivorous niche in early Paleocene North America. Over millions of years, they diversified into forms that specialized on specific plants, specific terrain types, specific feeding strategies. Some became runners, others became diggers, a few evolved crushing molars for grinding seeds. They filled the world so completely that when climate began to shift, when rain patterns changed and forests gave way to open grassland, there was nowhere left to go. Their specialization had painted them into a corner. Mammoths didn't repeat that mistake. Their teeth weren't locked into processing a single plant type. Their digestive systems could extract nutrition from grass, from shrubs, from bark, from fallen branches. Lean year or abundant year, they survived. Drought or flood, they moved. Predators hunted them, certainly, but a mammoth herd had behavioral flexibility that no condylarthid ever possessed. They could learn, they could teach, they could change strategy when the old one failed. What separated success from extinction wasn't size, it wasn't strength. Mammoths didn't dominate because they were larger than the creatures that came before. They dominated because they were smarter about being uncertain. Now, before we continue, I need you to understand something crucial here. This pattern I'm describing, this mechanism of how specialization leads to collapse and how flexibility creates resilience, isn't just paleontology. It's written into the bones of every extinct megafauna lineage we can study. And if you want to understand how mammoths, mastodons, saber-tooth cats, and giant ground sloths all survived and thrived while everything around them failed, you need to see the deeper framework. That's exactly what our complete guide covers in depth. The signals, the patterns, the evolutionary architecture that separated winners from losers across the entire Pleistocene. You'll find that guide in the description and pinned in the top comment. It's a paid resource, but frankly, if you're serious about understanding these animals as more than fossils, it's where the real story lives. Mammoths didn't arrive in a vacuum. They arrived into an ecosystem that had already spent millions of years sorting through solutions. The grass was already there because condylarths had failed to keep forests intact. The migration routes already existed. The predator-prey dynamics had already stabilized into patterns that favored large, mobile herbivores with strong social bonds. What condylarths couldn't do, mammoths did reflexively. They moved seasonally. They gathered in groups, sometimes family units, sometimes larger aggregations when resources allowed. Calves stayed with mothers for years, learning where water appeared in dry seasons, learning which plants were safe, learning how to behave around predators. Knowledge wasn't reset with each generation. It accumulated. And there's something else that separated the two. Condylarths were built for a world that no longer existed by the time they needed to adapt. Their body plans, their tooth structures, their digestive chemistries, all locked in. Mammoths carried adaptability in their very physiology. Thick fur for cold climates, massive molars that grew continuously, replacing themselves when worn down, trunk musculature that could manipulate objects, strip bark, or grab small plants with equal precision. These weren't incidental features. They were the machinery of survival through uncertainty. The Pleistocene wasn't kind to creatures that couldn't change their answer when the question shifted. Condylarths left behind skeletons that told a story of inflexibility. Their teeth, once ground down by coarse vegetation, couldn't regenerate. A mammoth's molars were replaced 6 times over a lifetime. A condylarth got what it was born with, and when those wore flat, its feeding efficiency collapsed. That single difference cascaded through everything: nutrition, energy, survival probability, reproductive success. Mammoths also had something Condylarths lacked entirely: behavioral flexibility encoded in their neurology. Their brain-to-body ratio, while not primate level, far exceeded that of early hoofed mammals. They could learn from experience. They could teach their young. Herds of mammoths discovered new migration routes in response to climate shifts and passed that knowledge down. Condylarths followed genetic scripts. Plasticity versus programming. The fossil record whispers this distinction constantly. We find mammoth remains clustered in ways that suggest intentional site reuse. The same valleys, the same water sources, visited across generations. Condylarth fossils scatter almost randomly, as though each population was responding to immediate pressure with no learned strategy to draw from. Now, before I take this further, I need to anchor something critical for you: the mechanisms that separated evolutionary success from evolutionary failure during this period. The specific pressures, the physiological responses, the cascading advantages, these are explored in complete detail in our deep dive guide on Pleistocene mammal adaptation. That resource breaks down the skeletal innovations, the metabolic shifts, and the behavioral architectures that determined which lineages endured. It's available in the description, and I've pinned it at the top of the comments. If you want to understand not just what happened, but precisely how it happened at the anatomical and biochemical level, that's where those answers live. Condylarths weren't failures because they were weak. They were failures because they were locked into body plans that couldn't absorb the shock of environmental change. Locked into feeding strategies that left no margin for error, locked into behavioral patterns inherited from an era when the competition was minimal and the climate was stable. The Eocene was their moment. They dominated it. But the Eocene didn't last forever, and they never developed the capacity to dominate anything else. Mammoths, when they finally arrived millions of years later, carried none of these constraints. They were built from the ground up for instability. Their massive size gave them thermal inertia, the ability to survive temperature swings without constant metabolic adjustment. Their social complexity allowed them to buffer individual losses through group protection and knowledge sharing. Their regenerating molars and adaptable trunk meant they could shift diet based on availability without reorganizing their entire physiology. There's a lesson folded into this comparison, though not the one that sounds obvious. It's not that bigger is better, or that later evolution is always an improvement. The real pattern is narrower and sharper. Adaptability outlasts specialization. Condylarths specialized in a particular ecological niche during a particular climatic window. That was perfect until it wasn't. Mammoths were generalists by Pleistocene standards. They could eat a wider range of plants, tolerate a wider temperature range, and adjust their social organization to different environmental pressures. When the question changes, specialists die, generalists persist. Hold on, I need you to focus on something for just a moment. This pattern of specialist versus generalist isn't some abstract evolutionary theory. It's the mechanism that explains which creatures vanished and which ones thrived through the entire Cenozoic. If you want to understand how to spot these patterns yourself, how to read the fossil record and predict which species might have made it or fallen short, that's precisely what our detailed guide covers. You'll find it in the description and pinned at the top of the comments section. It's a paid resource, but it walks you through the actual signals paleontologists use to assess extinction risk in deep time. Condylarths faced one direction and built their entire bodies for it. Their teeth were precision instruments for a specific diet. Their size was calculated for a warm, forested world where energy was abundant and predators were manageable threats. When that world contracted, when the continents cooled and the forests began their slow retreat northward, Condylarths found themselves holding a specialized ticket to a concert that had already ended. Mammoths inherited that same landscape, but they arrived with a different set of blueprints entirely. Their teeth were generalists' teeth, Massive grinding surfaces that could process everything from tundra grasses to woody shrubs to bark stripped from birch and willow. Their fur came in layers, with dense underfur that could trap heat in temperatures that would have killed most other megafauna. Their digestive systems were built to extract nutrition from food that other herbivores couldn't even eat efficiently. This wasn't luck. This wasn't Condylarths being inferior creatures or mammoths being superior. Evolution doesn't work that way. What happened was a simple, brutal sorting. The animals whose bodies could tolerate the new conditions survived long enough to breed. The ones whose bodies couldn't were sorted out. Condylarths were the first great mammalian herbivores of the Cenozoic, and they were successful for millions of years. That success led them into deeper specialization. They became better and better at extracting energy from the warm forests of the Paleocene and Eocene. Each generation fine-tuned the strategy. Teeth got more elaborate. Digestive systems got more efficient at processing particular plant compounds. Body size stabilized around an optimal range for that ecological niche. But when you become an expert at one thing, you become fragile in a world that demands flexibility. The moment that niche began to close, as oxygen levels shifted and temperatures drifted and atmospheric composition changed, Condylarths had nowhere else to go. They couldn't pivot. Their teeth were wrong for the new foods. Their fur was wrong for the new climate. Their metabolic rates were calibrated for a temperature range that was disappearing. Mammoths, arriving later, inherited a world that was already sorting creatures by adaptability. The ones that made it into the fossil record, the ones that survived the next few extinction pulses, the ones that eventually dominated entire continents, those were the animals whose bodies could change across a range of conditions. They didn't specialize. They compromised. They were good enough at eating many things, rather than perfect at eating one. This is worth sitting with for a moment. When we look at extinction in the Pleistocene, at why mammoths lasted so much longer than Condylarths, at why dire wolves could hunt across a continent while saber-tooth cats were locked into specific hunting strategies, we're seeing the same principle play out again and again. Flexibility survives. Specialization dies. Condylarths failed because they succeeded too well at something that stopped mattering. This is the secret I promised you at the beginning. This is why Condylarths matter more than their bones suggest. Their story isn't about failure, it's about the mechanics of failure itself. They didn't vanish because they were weak. They vanished because the world changed faster than their bodies could follow, and that pattern, that terrible rhythm of specialization meeting indifference, would echo through the entire Pleistocene. The mammoths that inherited North America didn't arrive as conquering giants. They arrived as generalists into a landscape already stripped of its most specialized competitors. They were broad-backed, adaptable, capable of surviving on vegetation that ranged from lush steppe to sparse tundra scrub. Their molars could grind tough plants. Their metabolism could slow in winter. Their social structures were flexible enough to split apart or gather depending on resource availability. They weren't perfect, but they were survivable. Condylarths had been perfect, and perfect turned out to be the worst thing you could be when the climate stopped caring about your expertise. What makes this so important for understanding Ice Age giants is this: mammoths, mastodons, dire wolves, saber-tooth cats, all the creatures that would dominate North America for the next 50,000 years. They weren't inheriting a virgin continent. They were inheriting a testing ground. The Condylarths had already run the experiment. Their extinction had already written the rules of survival in a cooling world. The mammoths that arrived learned, whether through direct competition or through the fossil record written into the landscape itself, what flexibility looked like. They learned that specialization was a trap. A saber-tooth cat that hunted only horses would die when the horses migrated or changed their migration patterns. A ground sloth that ate only one type of plant would starve when that plant shifted its range northward. But a mammoth that could eat grass, shrubs, leaves, bark, even tree bark stripped from stands, that animal would survive the century when the vegetation map of North America redrew itself completely. Condylarths hadn't learned that lesson. They had never needed to. Their world had been stable enough, and they had been successful enough within that stability that there was no pressure to adapt. Evolution hadn't forced them to become generalists because specialization was paying off. And then, without warning, it stopped paying off. The climate tipped. The forests retreated. The world they had perfected themselves for simply ended. The mammoths didn't know they were the beneficiaries of an extinction that had happened millions of years before they ever walked onto the continent. They didn't know that Condylarths had already proven the fatal cost of being too good at the wrong thing. But their bodies knew, their genetics knew, the species that survived long enough to breed, long enough to pass on their genes, long enough to walk across Ice Age North America with their herds intact. Those were the ones built for a world that didn't stay still. Here's what we often miss when we look back at the Pleistocene. We see the mammoths and we see them as inevitable. They seem so perfectly suited to the Ice Age that we assume they were always going to win. But the real story is stranger and sadder. They won because an entire lineage of earlier animals had already lost. The Condylarths didn't fail because they weren't clever. They failed because the world stopped being the world they were clever at surviving in. And that same catastrophe, playing out over millions of years instead of thousands, would eventually catch up with the mammoths too. Every extinction in the fossil record contains a Condylarth, some creature, perfectly adapted to a world that no longer exists, unable to change fast enough to keep pace with the climate shifting beneath its feet. The mammoths inherited the Earth not because they were the best animals ever to walk the planet. They inherited it because they were flexible enough to inherit a planet that was changing. Specialization was the trap. Generalization was survival. The lesson we can take from the Condylarths, the one that still matters now, is this. The world will change. It always does. The animals that survive aren't the ones that perfect themselves for the world as it is. They're the ones that keep themselves ready for the world as it might become. Specialization feels like strength, but flexibility, the ability to eat many foods, to live in many places, to adjust without breaking, that's what lasts. Thank you so much for sticking with this story all the way to the end. If the world of Pleistocene giants fascinates you the way it fascinates me, please hit subscribe so you don't miss the next deep dive into these incredible creatures and the ecosystems they shaped. Drop a comment and let me know, which Ice Age animal do you think had the best survival strategy? And turn on your notifications so you catch every new video the moment it goes live.